Welcome again, students, to another session of maths. Today we're going to dive right in and we're going to look at area of triangles. Okay? Here we just need to pick up many of the skills that we have followed through from similar triangles. You would have done congruent triangles. And now we just to complete the area of calculating the area. Now we have this formula here, and I'm sure most of you know it. The area of a triangle is half base times height. I'm not sure if everyone knows where that formula actually comes from. It actually comes from rectangles. If I had to draw a rectangle, and if we had to cut this rectangle into blocks, and let's say each block is 1, then I would be able to work out the area of this. Okay? And if I wanted to then find the area of a triangle, that would be half that area. All right? So what is the area of the rectangle? It's length times breadth, which is, again, we say this is going to be the height, and this is going to be the base. So if that is the area of the rectangle, then this is half base times height. What happens if I have a figure that looks like a parallelogram? How can I find out what the area is? We talk about the area being the height times the base. What happens is, this is what we do. We actually take out this piece from here and we stick it here. And what do? We make that parallelogram a rectangle. And again, we say base times height. So if I want half of it, which happens to be a triangle, I get the area for the triangle. Simple as that. That is the area for a triangle. So when you see half base times height, this is where we are getting it from. Okay, let's have a look at a problem. So the formula that we've derived is area is half AB sine C. Now when we look at the triangle, how do we label A, B, and C? A and B must be the two sides that includes the angle. Okay, so the angle must be between the two sides. And then I can substitute the values for that into this to find the area. Right, we can show that for any of these triangles, BC sine A. So if I have angle B, then I can use C and A. If I have angle A, I can use B and C. If I have angle C, I can use A and B. So as long as I have two sides and the angle in between them, I can work out the area. Okay, so that seems fairly straightforward. Let's have a look at this example. There's a trapezium. There's all the information. 12 centimeters across, 16 centimeters that way. There's some angles, and there's that dimension. And what is the question? Find the area. All right, area of a trapezium, half the sum of the parallel sides, which I don't have, times the height, I don't have, because this is not, the height must be at 90 degrees, okay? So this is at 80 degrees, so I can't use the trapezium formula. But if I look at this, I've got the two sides and the included angle. That's a triangle, so I can use the area formula. If I look at this triangle, ABC, that is not an included angle. So I need to find out the angle at A. So then I can use that area formula and add the two triangles. So how do I find angle A? These are parallel lines. Always remember to look for these things. So if the lines are parallel, all the angles in between them are supplementary, so they all add up to 180 degrees. So using that fact, I can work out angle A. So BAC plus 35 plus 80, 180 degrees. So that tells me what BAC is. And then the area of the trapezium is the area of the two triangles. And I substitute then half AB sine C. So half AB sine C and half 12 times 16. 12 times 16, sine 35. And that's your answer. Okay? Correct to 1 decimal place. Now let me just make a note about this, because students quite often don't do this. When the question says, give your answer correct to 1 decimal place, that is 1 decimal place. If they asked, give your answer to 2 significant figures, that is different from decimal places. 2 significant figures would be 1.2 times 10 to the 2. Okay, so be very careful about what is decimal places and what is significant figures. All right, let's just have a look at another example. There's a little bit more complicated. We have what is called a sector. Okay, and this is part of a big circle. Right. So the area of that OAB, the triangle, is 40. Find the area of the shaded region. All right. Give your answer in this case to 3 significant figures, different from decimal figures. Let's have a look at how we do this. Right. The area of this triangle is what? Half AB sine C. So if this is a circle, then I know that OA is the radius and OB is the same radius. So I have 2 sides. I don't have the angle in between. I need to get that angle. Now the question is, why would I be looking for that angle? If I want to work out the area of a sector, then I need the angle, because that proportion of the angle over the whole circle gives me the area for a sector. A sector is basically a piece of pie from a whole pizza. Think of it that way. And that is a fraction. That fraction is dependent on the angle. Okay? So the first thing is to find that angle. And I can do that using the area for the triangle, half AB sine C. And if I solve that, you will see sine of AOB is 0,512, which means the angle is 30 degrees. Okay? And using that angle, I can then work out the area for the sector, which is the fraction of the entire area of a circle, which is pi r squared. Okay, so that is the area of the sector, which means if I subtract the area of the triangle, 40, I will get the answer. Now, 3 significant figures, 1.99. Okay, that means 2 decimal places, but 3 significant figures. Last thing we're going to look at in area formula is Herons formula. And I put this at the end because my experience so far has been that teachers start with this, which is sort of like putting the cart before the horse. Because this formula depends on trigonometry and right angle triangles and things that came a lot after what we study. So we learn this formula first and we cannot derive it. To actually work out this formula is pretty crazy. It's some very intense maths in trigonometry, but we teach this first. I don't know why. Okay? This idea is a lot more simple. We can understand that. We have a rectangle, we chop it up, we find the area for the triangle. This one is not so straightforward. But the formula is very nice because if I have 3 sides of a triangle, I don't need to work out heights, I don't need to work out angles. I can just use the 3 sides and work out the area. And that is dependent on this little calculation here. We say we must work out half the sum of A plus B plus C. And once we have that, we can stick it into this formula we call Herons formula. S minus A, S minus B, S minus C. That's very easy to remember. If I think of Herons formula, I know it's a square root, yes. How do I put the terms inside? S minus A, S minus B, S minus C times S. And you can substitute those values and work out what the area of a triangle is. So we have 3 formulas for the area of a triangle. Half AB sine C, Herons formula, and half A times H, half base times height. So 3 different ways to find out the area of a triangle. I hope that was beneficial to you guys. Thank you.